The last lesson in the kit is set up to be a 3-day investigation to discover the identity of a mystery powder. Students in small groups are presented with a jar containing a mystery mixture of 2 or more powders, and the small groups must carry out a procedure to determine what ingredients are in their mixture. Students are given access to a variety of powders from the kit and run these powders through a series of tests. A lab sheet is included in this lesson for students to use. But whereas the teacher in the lesson has students carrying out the tests on the lab sheet, which when I tried it, it really got messy. And I'm not sure I would recommend our students try to do this too. What I found is that the samples, when I applied water to them, they very quickly started to want to run together, which contaminated the evaporation test and would really, I think, serve more to confuse our students than benefit them. Instead, we have excellent supplies from our kit. So we've got tons of plastic cups of various sizes, so we can utilize these. Instead of evaporating on our lab sheet, I'd recommend we use the evaporation dishes from the kit as well. On day 1 of the investigation, students in small groups place pinches of each powder in a labeled column on the sheet, or my recommendation, in its own labeled cup. And then they're going to place 2 drops of grape juice on each powder and observe the results. Then they're going to place another pinch of powder on an evaporation dish, and they're going to use a syringe or the cylinder, the test tube cylinders, to place an adequate amount of water on the evaporation dish to let that solution then dry overnight. On day 2, the class will review how mixtures may sometimes cause a change in properties. And then the small groups will perform a vinegar test on each one of those powders, following the same procedure as they did in day 1 with the grape juice test. On day 3 of this investigation, small groups repeat the procedure of the vinegar test, except this time they'll use iodine. The iodine will react differently if cornstarch is involved in the mixture. Iodine will turn the cornstarch a green color, whereas all the other powders should be yellow. After this test, small groups each receive their own mystery mixture, and they will perform the same 4 tests on the mixture as they did on each one of the powders that they have. The ingredients in the mystery mixture is never clearly identified anywhere in the lesson plan, but we can turn this ambiguity to our advantage. We can differentiate this investigation for each one of our small groups by giving different small groups their own mystery mixture. Some ingredients are easier to discern because they react in unique ways, like the vinegar will cause baking soda to bubble, and iodine will cause the cornstarch to turn green. Other ingredients may require more precise observations of the evaporated crystals and measurements of mass to be able to tell how much of the solute or the powder dissolved into the water in order to tell the mixtures and the powders apart. These kind of mystery mixtures can be reserved for students who might become disengaged if the investigation is too straightforward or easy. Regardless of which small groups receive which ingredients, the big idea is to have students use the results from their tests as evidence to back their claim for what they believe was in their mystery mixture. Students should also use discrepant results, such as the cornstarch turning green while the other powders did not turn green, as evidence that a change in properties has occurred, which aligns with standard 5 PS 1.4.